Assalamu alaikum wa rahmatullahi wa barakatuh, dear grade 8 students. In this video and in the coming videos, inshallah, I'm going to make training exercises about proving a square. And I'm going to focus on proving a square using sides, vertices, or using diagonals. So that's what I'm going to do in this video and in the coming videos, inshallah. First of all, let's make a little revision about the properties of a square. Let me construct a square, for example, of side 3 centimeters. So as you see here, I'm drawing a square ABCD of side 3 centimeters, and I'm going to talk about the properties of that square. So as you see here, we have 4 equal sides. The square has 4 equal sides, as well as for the vertices, they are all equal and each one of them measures 90 degrees because, as you know, the total sum of angles in any quadrilateral is 360. When I divide 360 by 4 equally, I'm going to get 90 degrees for each vertex, and that's why all the vertices of the square are right. So to prove a square, it's enough to prove that all of its sides are equal and there is a right angle. One right angle is enough because definitely I'm going to get that the others are right, because if this is right, then this is right because they are cointerior angles, and as well as this one and definitely this one. So it's enough to just prove one angle is right or one vertex is right and that all the sides are equal. That's according to proving a square using sides. Now what happens if I'm going to prove it by another way using the diagonals? What I should use is that the diagonals must be proved equal. So as you see, the diagonal here measures 4.24. Okay, these black ones are for the diagonals. Okay, so the diagonals must be equal. They must bisect each other. What does that mean? Bisect each other means that they meet at their midpoint. As you see, E is the midpoint of A and C, and E is the midpoint for BD as well. So the diagonals should be equal, bisect each other, and definitely they should be perpendicular. Let's make sure of the angle between these diagonals. As you see, definitely it is a right angle. So the diagonals must be equal. As you see, they must bisect each other. The distance from E to B is exactly equal from E to D, and similarly for the distance from E to C is exactly equal to that from E to A, and they have to be perpendicular. So diagonals of the square must be, to prove it a square, the diagonals must be equal, perpendicular, and bisect each other. Now let's start our training exercise. That's our first training exercise. As you see here, you have a circle. I'm going to mix between a circle and a square because I need to review some about the circle, its radius, the tangent to a circle, and so on. So here given a circle C, as you see, of center A and radius 4 centimeters. So the circle is C of center A and radius 4 centimeters. That line T is a tangent to the circle, okay, at point D. B is any point on T in such a way that DB is exactly equal to the radius. It's equal to 4 centimeters. Now E and C are the symmetric of A and B with respect to D. So again, I will repeat the idea of the symmetry. What's the idea of the symmetry? When I say that E and C are the symmetric of A and B with respect to D, that means that D is gonna be the midpoint of EA and the midpoint of CB. So with respect to D means that D is like a mirror, and A is gonna have its symmetry here, and similarly for B it's gonna have its symmetry here. Okay, so D is a midpoint for AE and BC as well. That's about symmetry with respect to D respectively, means that E is for A and C is for B. That's according to plotting E and C. Of course, I need to plot E and C, and thus I'm going to join A, B, E, and C to get my square. So as you see, I joined A to B to E and to C, and thus I got a square. The first idea here is that I'm going to prove a square, but what idea should I use? Should I use the idea of sides and one right vertex? Sadly, no one tells me that this angle or whatever is right, but I'm sure that this angle is right. Why? Sorry, I'm sure that this angle BDA is right. So as you see, it's 90 degrees. Who can remember why is this angle right? So this angle is right because it's the angle between the radius and the tangent. This is the point of tangency between that blue line, which is the tangent to the circle. And by definition of tangent, it's a line that's perpendicular to the radius at the point of tangency or the diameter at the point of tangency. So it's clear that I'm going to use the diagonals. I'm going to prove that this is a square using its diagonals. So let's code my figure. These two are equal. That's a given. dB is equal to dA. I have also that dA and dE are equal because of symmetry, as well as dB and dC are equal again by symmetry. So let's arrange my ideas. Let's organize the ideas. I need to prove that the diagonals are perpendicular. It's true, they are perpendicular because of tangency. I need to prove that the diagonals bisect each other. That's definitely true because as you see, D, that center of the square, it's going to be called the center of the square later. That point D is a midpoint of BC, the first diagonal, and AE, the second diagonal. So they definitely bisect each other at the same point D, or at the midpoint D. Now, are these diagonals equal? Let me see. The distance from here to here is 4, as well as that one. So all of that diagonal measures 8 centimeters. Similarly for that diagonal, and thus the diagonals are equal. So I satisfied the three conditions that they are, for the diagonals, they are perpendicular, they are bisecting each other, and they are equal as well. By this, I conclude that ABEC is a square using its diagonals. Now, let's see the proof written in an organized way. As you see here, as I told you, angle BDE, that one is 90 degrees. So BDE or BDA, whatever, we can use any one of them. BDA or BDE, of course, are each one of them is equal to 90 degrees, and that's because angle of tangency. So again, I can mark this angle B, D, and E. Okay, let me start from here. So I can mark this angle. Okay, that's 90 degrees and that's 90 degrees. So BDE is 90 degrees because it's an angle of tangency. Then I say that BC is perpendicular to AE, sorry. Okay, now I say that DB is equal to DC and DA is equal to DE by symmetry. So as you see, that's point D. Let me put it here to be clear. So DA and DE are equal, DB and DC are equal by symmetry. Then I say that the diagonals BC and AE bisect each other at D. So as you see, the diagonals BC and AE bisect each other. So I maintained two conditions, that they are perpendicular and that they bisect each other. Now, I need to prove, suppose I don't have measurements, I just have that BD is equal to DA without knowing the measurements. So how should I prove that all of AE is equal to all of BC? All what I have to write is that since I have DB and DA also equals, so as I always tell you, I always keep telling you that I take parts up and down, left and right, and then I search for two equal parts that are making the 90 degrees between them. Okay, I keep telling you that. So I take two equal pieces up and down, left and right, and now I have to take two equal pieces that make an angle between them, either that way or that way or that way or that way. These two equal that are given are DB and DA. So I say, but DB equals to DA, then by comparison, I can deduce that the four pieces are equal. DB is equal to DC is equal to DA is equal to DE. And now, if I collect DB and DC to add them, and if I collect DA and DE to add them, I'm definitely going to get BC as for that one and AE as for that one, and that's the addition property. So DB plus DC is going to give all of BC, and DA plus DE is going to give all of AE, and by that I proved that the diagonals BC and AE are equal. Thus ABEC is a square because its diagonals BC and AE are equal and bisect each other. So the diagonals are equal, perpendicular, and bisect each other. The three conditions are maintained: perpendicular, as for that 90 degrees, bisect each other, and equal as done here. Now I just have to remind you of the area of a square. For the square, the area is usually equal to the area of the square is usually equal to side times side, or side exponent 2 or side squared. But what should I do if I don't have the side? I use the property concerning the diagonal. The area of the square is also equal to d squared over 2. That needs a proof, and I'm going to prove it in a certain video inshallah, but this is a property that everyone can use. So the area of the square, if I want to use the diagonals, is d squared over 2. That's why, let's see what about the area of that square. So area of ABEC, I have that this piece is equal to 4 and this piece is equal to 4, then all of the diagonal is equal to 8. So diagonal squared over 2 means 8 squared over 2, which is 64 over 2, which is 32 centimeter squared. And that's for a new idea for the area of a square if I don't have the measurement of the side. Okay, so if I don't have the measurement of the side, I don't use that the area of the square is equal to a squared. I just use the area including or concerning the diagonals. That's equal to d squared over 2. Thank you, and inshallah we'll meet in another video talking about our proving a square using certain method.